What's up YouTube? It's that tutorial guy again with another math tutorial. Today we're going to be doing some geometric series. Now, this is not your typical Algebra 2 geometric series, this is your typical BC Calculus geometric series, which basically is talking about convergence of this series, whether it converges or diverges. So you're going to have some AN, right? And it's going to be equal to AR n, and this n is raised to this r. It also might be written as ar n minus 1. Again, this n minus 1 is raised to the r with the stipulation that n is greater than or equal to 1. With this previous one, the stipulation is that n is greater than or equal to 0. This is better shown with your summation symbol, where you have your n equals 0, your infinity up here with your AR to the n. And this is what you're going to be given, pretty much. Some constant multiplied by some ratio raised to the nth power. And what you want to do here is you want to look at your r, your ratio. Now, if the absolute value of this r, because it can be negative, is less than 1. If it is less than 1, then the series is going to converge. If it is greater than or equal to 1, the series is going to diverge. And the cool thing about this convergence is that not only do you know that it converges, but you also know that it converges to A1, that's a 1, A1 over 1 minus R. So it converges to this number, whatever this number is. Just call it big N for now. So yeah, it's pretty straightforward, and it's fun because you do get to use this formula, which is probably the one you learned in Algebra 2, or Algebra 1, or Algebra, whatever algebra class you took. So real quick, we'll do an example. It'll give us a summation as it's going to infinity, n equals 0, and we're going to have 4 over 3 multiplied by 1 over 3 to the n. This is a pretty straightforward geometric series. You can see that we have our an, our r, and of course our n. This 1/3 is our r, and being it less than 1, we know that this series converges by geometric series test. Now we can also figure out our n, our little thing up here that I labeled n. So our a1 is going to be whatever our first term is. When you plug in 0, you're going to get 4/3 multiplied by 1/3 to the 0, which is going to be 1. So our an is equal to 4/3. We can put this, 4/3, over our 1 minus r, which is going to be 2/3. This cancels out, and this is going to end up giving us 2. So let's do one more example. Do our little summation with infinity, n equals 1 this time. We're going to multiply 4 by negative 1 to the n minus 1 over 3 to the n minus 1. Now this one, you can see that both the exponents on the top and the bottom are the same, so we can actually rewrite this as 4 times negative 1/3 to the n minus 1, at which point it doesn't become that hard, because we can obviously see that this negative 1/3 is our r. And with negative 1/3 as our r, this series converges. And with that, we can take our a1, which we'd have to plug in our 1 for. Let's do that real quick. This would be 0, that'd be 1, it would be 4, a1, 4, over 1 minus negative 1/3, which gives us 4/3. That's equal to 3. So there you have it. That's the geometric series test. We'll be doing more series tests to come, and I hope you enjoyed.